Hello everyone. In this video we will learn about the solution of linear equations in two variables or three variables by using matrices. Suppose we have a system of linear equations in two variables, that is a1x plus b1y equal to c1 and a2x plus b2y equal to c2. Then what we do, we will make a matrix A. In that we will take the coefficients of x in the first column and the coefficients of y in the second column. That will be a1, a2, b1, b2. Another matrix, we will have a column matrix that will be represented as capital X, and in that we will have the variables. These are x and y. Another matrix, we will have B, and that will also be a column matrix, and that will be of the constant terms C1 and C2. Now we call something known as matrix equation. Matrix equation for the given system of equations, that is AX is equal to B. You can see very well here, if we write A1, B1, A2, B2 into X, X, Y equal to B, that is C1, C2. We find that when we multiply this to this, A1 into X plus B1 into Y will be equal to C1. A2X plus B2Y equal to C2. And that is why it is known as the matrix equation of the system of linear equations which is given to us. Here A is known as the matrix of coefficients, or we call it coefficient matrix. Suppose we have a system of three equations in three variables, that is a1x plus b1y plus c1z is equal to d1. a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z equal to d3. Then here we will have A as a1, a2, a3, b1, b2, b3, c1, c2, c3. X will be x, y, z, and we will have b equal to d1, d2, d3. Then again we write the matrix equation here is Ax equal to b. As I told you, this A is known as the coefficient matrix. So like this we can make the matrix equation for any of the given system of equations, whether it is in two variables or three variables or maybe more than three variables also. See, after getting the matrix equation Ax is equal to B, when we want to find out the solution of the system of linear equations, means we have to find out the values of the variables which satisfy the given system of equations. So what we do here, we have to find the value of x. We have to eliminate this A from here. For that what we do, we will multiply A inverse on both the sides. That is A inverse into A into x is equal to A inverse into B. A inverse into A is I, that is I into x is equal to A inverse into B. And we know I into x is x, so we get x is equal to A inverse into B. It means we can find out the inverse of matrix A, and when we multiply it to B, we get the value of x, that is we will get the value of all the variables. Also we know that A inverse is given by adjoint A upon determinant A, And hence we say here, if determinant A is equal to 0, A inverse does not exist. And if A inverse does not exist, we may not get the solution here. It means we have to think about determinant A to be 0 or non-zero. Then we have the conditions. Number one condition says, if determinant A is not equal to 0, it means matrix A is non-singular. Then we will have a unique solution. And if we have a unique solution, then we say the system is consistent. We know the system is consistent when we have one or more solutions of the system of equations. And we say inconsistent when there is no solution of it. Now the second case comes if determinant A is equal to 0. We know that A inverse does not exist. It means what we will do, we will find the value of adjoint A into B. Then depending on the value of adjoint A into B, we will decide what type of solution is there. We get two cases here again. Number one case says if adjoint A into B is equal to 0, then there are infinitely many solutions. And if there are infinitely many solutions, it means the system is consistent. The second case may be if adjoint A into B is not equal to 0. Then we have no solutions. And if there are no solutions, means the system is inconsistent. So what we will do, we will try to find out determinant A first and then we will decide what to do. If we are finding it is not equal to 0, then we will go ahead with the solution x is equal to A inverse into B. And if determinant A is 0, then we will find out adjoint A into B. If adjoint A into B is 0, then there are infinitely many solutions and the system is consistent. If this is not equal to 0, then there are no solutions. It means we can say the system is inconsistent. We discuss one example for the solution of pair of linear equations in two variables. And the equations are 2x plus 3y equal to 7, the first equation, and the second equation is 3x minus 2y equal to 4. To find the solution by using matrix, we have to make the coefficient matrix first, that is A equal to the coefficients of x 2 and 3, coefficients of y 3 and minus 2. Then x, variables x and y. Then the matrix of constants B, that is 7 and 4. And now we make the matrix equation for the given system of equations, that is matrix equation Ax equal to B, which implies that x will be equal to A inverse into B. To find the solution, first of all we have to find out the determinant of A. Determinant A here is 2, 3, 3 minus 2, which is minus 4 minus 9 minus 13. It is not equal to 0. It means A inverse exists. And if A inverse exists means the system has unique solution. This implies that the system of equations has unique solution. Now we have to find out inverse of A, and for that we have to find out first of all cofactor matrix, that is Cij, and that we know how to find. First we write the signs, plus, minus, minus, plus, and then we have to use the minus. The minus here are, for this 2 it is minus 2, for this 3 it is 3, for this 3 the 3, and for minus 2 it is 2. This is equal to minus 2, minus 3, minus 3, 2. It means the adjoint of A will be equal to the transpose of Cij, that we know, and that will be equal to minus 2, minus 3, minus 3, 2. Now we know that A inverse is equal to adjoint A upon determinant A. Determinant A is minus 13. So this will be minus 1 upon 13 into the adjoint. That is minus 2, minus 3, minus 3, 2. If we multiply minus 1 to every element of the matrix, that will be 1 by 13, 2, 3, 3, and minus 2. And now we know X is A inverse into B. That is 1 upon 13 into 2, 3, 3 minus 2 into B. B is 7, 4, which is equal to 1 upon 13 into 14 plus 12, 26. 21 minus 8, that is 13. If we divide this by 13, it will be 2, 1. So we are getting X is equal to 2, 1. It means XY is equal to 2, 1. This gives us the values of the variables. X is 2 and Y is equal to 1. Now we discuss a system of 3 equations with 3 variables. The equations are given here. First of all, we have to make the coefficient matrix, that is A, and here we are taking the coefficients of X, that is 2, 3 and 1. Coefficients of Y in the second column, minus 3, 2 and 1. Coefficients of Z in the third column, 5, minus 4, minus 2. And now we find the value of the determinant of A, so that we can find out whether the system is consistent or inconsistent. We find the value of determinant expanding along row 1. We know how to find out, and that is coming as minus 1, which is not equal to 0. So we can say that A is non-singular matrix. It means the system of equations is consistent and it has a unique solution. Now we go for finding A inverse, and for A inverse we have to find the Cij, that is cofactor matrix of A. We know how to find it out. Then we can find out adjoint of A, that is the transpose of this Cij, and that is coming at 0, minus 1, 2, 2 minus 9, 23, 1 minus 5, 13. And then we know that A inverse is adjoint A upon determinant A. That will be 1 upon minus 1, because determinant A is minus 1. And when we multiply this minus 1 with all the elements of the matrix coming as 0, 1, minus 2, 9, minus 23, minus 1, 5, minus 13. Now we know what is X. X is the column matrix of variables, that is X, Y, Z. What is B? The matrix of constants, and that are here 11, minus 5, minus 3. Then we know the matrix equation. That is AX is equal to B, which implies that X is equal to A inverse into B. X is X, Y, Z. A inverse is 0, 1, minus 2, minus 2, 9, minus 23, minus 1, 5, minus 13 into B, that is 11, minus 5, minus 3. Finding the multiplication, we are getting here 0, minus 5, plus 6. This is minus 22, minus 45, plus 69. And this is here minus 11, minus 25, plus 39. Which gives us 6 minus 5 is 1, 69 minus 67, that is 2. 39 minus 36, that is 3. It means we are getting here x is equal to 1, y is equal to 2, z is equal to 3. This is the answer. This is the way we can find the solution of the system of 3 equations with 3 variables. We discussed now one problem based on the system of linear equations in 3 variables where we find infinitely many solutions. And the equations are x plus y plus z equal to 6 is the first equation, x plus 2y plus 3z equal to 14 is the second equation, and x plus 4y plus 7z equal to 30 is the third equation. First we find the coefficient matrix A, and here we are finding the coefficients of x 1, 1, 1. Coefficients of y in the second column, that is 1, 2 and 4. The coefficients of z in the third column, that is 1, 3 and 7. X, the matrix of variables, x, y, z, this is a column matrix. B, the column matrix of the constants, 6, 14, 30. Now we know that the matrix equation for this will be Ax is equal to B. Now we find the value of determinant A. We are writing the determinant, and then we know how to expand it along row 1. The value of the determinant comes as 0. If it is 0 means A inverse does not exist, and if A inverse does not exist means the matrix A is singular matrix, and then the system may be consistent or inconsistent. For that we have to find out the value of adjoint A into B. To find adjoint, first we have to find out the cofactor matrix Cij, that is 2 minus 4 2, minus 3 6, minus 3 1, minus 2 1. Then adjoint A we know is the transpose of this Cij, and that we are finding here, that is the elements in row wise are 2 minus 3 1, minus 4 6, minus 2 2, minus 3 1. And then we find the product of adjoint A and B. Adjoint A into B, when we multiply the matrices, we are getting is coming as 0 matrix. And if it is 0 matrix, then we know the system is consistent with infinitely many solutions. To find these infinitely many solutions, what we do? We consider any of the variables x, y or z as an arbitrary constant, either k or lambda or anything else. Generally we take it as z as k, and here also we are taking z as k. We will substitute this value of z as k as the arbitrary constant in these 3 equations. From the first we are getting x plus y plus k equal to 6, or x plus y equal to 6 minus k. From the second equation we get x plus 2y plus 3k equal to 14, or x plus 2y is equal to 14 minus 3k. From the third we get x plus 4y plus 7k equal to 30, or x plus 4y equal to 30 minus 7k. And now we are getting a system of equations in 2 variables, and that is also linear equations. We know how to solve them by elimination method or by substitution method. By solving these equations, what we find? We are getting the value of x as k minus 2, y as 8 minus 2k, and z is equal to k. How can we say that these are infinitely many solutions? Actually, see, we have taken k as the arbitrary constant. So we can change the values. Whenever we change the values of k, according to that we will be getting the value of x and y which satisfies the system of equations. And hence we can say that these are infinitely many solutions. In the next video, we will be learning about the homogeneous equations and their solutions by using matrix. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.